I'm a research technologist and also a PhD student working on precision turfgrass management. Anybody know what precision turfgrass management is other than Joe? Okay, so my previous background was in row crops, so it's like precision ag where we're trying to apply the right amount of fertilizer or right amount of product in the right place at the right time. So sort of the 3 R's. So what I'm focusing on is using remote sensing technologies, so different sensors, drone technology or satellites, to try and gather information from there so we can figure out how best to use that data, create a decision tree, and ultimately a guide for turfgrass managers to help maintain a consistent growth and quality of their turf while varying their fertilizer and other inputs, and ultimately helping try to reduce their costs. So what we're standing on right here is my East Campus plots, where we're fertilizing at different rates. And so the side you're on right now, these have only been rain fed, only rain irrigated, so you can see they don't look all that great. When it was at 100 degrees for over 2 weeks in July, these really just dried up. And then we put on some water just so that we didn't completely kill them. But the sprinklers, you can see behind you guys where the wind would just knock it out of the way, and we just really didn't get a lot of water on there. They'll come back, but it's helped capture some great data for me so that eventually when we're using these numbers, I can tell you it's not just a number, should maybe tell you if you need to apply water or apply fertilizer, or maybe it's a disease problem. And then on the other side over there, those just been kept irrigated at 80% ET, so deficit, little bit of a deficit irrigation throughout the year. Both sides have gotten the same rates of fertilizer every 2 weeks, so either have gotten 0 pounds of N per thousand, so absolutely nothing, trying to basically see how the mineralization works in the soil, all the way to over applying at 0.4 pounds of nitrogen per thousand every 2 weeks, which is just way too much. But when it was really dry, we could really tell some differences in how much N. You could see a lot darker color on that over applied fertilizer plots on the water side, whereas on the dry side it was just trying to hang on, but the over applied was doing a little better. So when I was talking about precision turfgrass management, we're trying to apply the right amount at the right time in the right place. Some of the tools that we've been trying to use, or that I've been using, are different sensors. So has anybody used a TDR? So used a lot in golf courses. Basically, you know, it's going to depend on what part of the golf course you're at, whether you're on a fairway or a putting green, and even the type of turf that you're using. So with this creeping bent grass, it's going to look different than the one we see where Bill was talking about over on that low input, because it's I don't remember the varieties names off the top of my head, but that's all going to depend on what you as the turf manager perceive as an acceptable quality. But so we can hopefully get some data. We've been getting data off of this. We've seen about half as much volumetric water content on this dry side as on the wet side. But that'll help us correlate with the different sensors that we're using, so that if you're using one of those sensors and you just don't have that TDR out there that day, maybe you can glean some we can hopefully glean some information off of it to help see if you need to apply water or if it's something else. So part of my project, we're also working out at the Jim Ager golf course, where we're doing a little less high intensity sampling, but we're doing a lot of different remote sensing technologies. So one thing we're using is this GreenSight agronomics drone. It's a company out of Boston. It's fully autonomous, so all I have to do is go out there. We set it on one of the tees and we follow around the course to make sure it doesn't hit anything, or if there's a really high wind we can control it. But it just follows a pattern and gets data for us. It has a thermal camera, so we can tell how hot that turf is. So when we flew it the last time, Parker, the superintendent out there, he hadn't watered as much as he should have, and so you could really tell it was really hot and dry. Whereas where it had been watered, a lot cooler. And then it also has a visual camera, so you can just see what the grass looks like, and also get some NDVI data. So it's pretty handy So we're trying to figure out what values you get from that, how we can better use that for turf managers. And then if we look at our fairway mower for out here, that sensor unit up there on the top, that's a GPS unit. And then on the back of it, there's a sensor there that gives us NDVI and NDRE. And so those two indices are used to help, they're a proxy to see how green that grass is, how healthy it is. NDVI was originally made for row crops, so it works well when you have exposed soil. So it's not as sensitive, it doesn't tell you as many differences on a golf course or just turf grass settings. Because if we see soil, we know we've done something really bad, and we want to tell the differences on a steady canopy. So that NDRE, it's called normalized difference red edge. It takes the values of near infrared reflectance from the grass and red edge reflectance, and it gives us values. It works better in a steady canopy like we see in turf, because that red edge part can really tell the differences in nitrogen content and water content of that grass. But that's not exactly super helpful, because I can get you all these values, but we're trying to figure out if you get this value, how much water maybe you need to apply, or if it's water you need, or if it's fertilizer, or if maybe there's another problem going on. So that's why we're trying to create this decision tree, and we're using a bunch of other sensors. So it just looks like I have a bunch of toys out here, and sometimes that's what it feels like. So this thing right here, it's from Spectrum. Not trying to sell you anything, but just showing you, it's a chlorophyll meter. So this, and up right here, this is a sunlight sensor, because this is a passive sensor. And what I mean by passive is your value is going to change depending on how much sunlight is out during the day. So if you go out, use this sensor, another passive one like our drone over there, and you're out at 9 o'clock versus like 2 o'clock or 1 o'clock in the afternoon when you have full sun on a sunny day, your values are going to change based on the time of day and where the sun's at. Or if there's a lot of cloud cover versus sunlight cover, that's really going to change the values on a passive sensor compared to an active sensor like that mower over there and this other handheld sensor. And so these differences, passive sensors, if we look here, one of these sends out a beam of light, and then it measures the reflectance back from that light. So it won't matter, I mean, we're not going to tell you to go out and measure stuff in the middle of the night, but you should still get the same answer as you would at 2 o'clock in the afternoon if it's sunny or cloudy, because it all depends, it's measuring it from the beam of light that it sends out. So this one, it's just another sensor that gives us NDVI, NDRE, just giving me more information to help create that decision guide to figure out whether you need to apply water or fertilizer or something else. This is just another one. This is another passive sensor that just does NDVI, so still just trying to create that story for you guys. And so those are most of the toys that we're working with. And then I don't know if Bill was telling you earlier, but he likes to have all of his grad students collect clippings. So on all these plots, we take one strip and collect clippings so we can get a proxy of what the growth rate is on that grass. So over here on the dry side, obviously we haven't been getting as much growth as on that wet side, especially with the high fertilizer ones. We could just see it. I mean, that's nothing new for me to tell you, but that gives that growth rate in combination with the different sensors that we're using will help me be able to create a correlation in that algorithm and decision tree on what type of remedy or long-term action that should be taken on this turf. And then on top of that, we also taking lab samples from these clippings, so to get that true chlorophyll content and nitrogen content of the grass. So seeing how much chlorophyll is actually in there. So the more chlorophyll, the healthier the turf, more nitrogen. You know, we'll see if the amount of nitrogen we're getting in there is actually being taken up by the plant, or if the ones that we're over applying, is it just going out into the root zone and not doing anything. But so one of the big things with precision turf, as I don't know if Bill told you, but on that low input one, we've been doing work with this handheld scanner where if it falls below a value of 0.28 for NDVI or NDRE on that creeping bentgrass, we know that it's also fallen below an acceptable quality that we want. So we'll go back in and apply fertilizer on that. And by doing that, we've been able to reduce the amount of fertilizer we've applied by 50 to 70% compared to a traditional method. So on top of saving money from less fertilizer on it with using these sensors, you can also help maintain that consistent quality by using some remote sensing technologies and more precision turfgrass management. Obviously, unfortunately, I don't have a lot of data to tell you guys, but we'll be doing this project for the next couple of years in hopes that we can create that decision tree so you can get a value, and then we can create a guide so that if you know what value you get, these are some of the options you can get or options you can do to remedy that, rather than just solely relying on how the turf looks like, just helping create some more information for everybody.